Hello everyone, my name is Thao Nguyen. Today is a great opportunity for me to explore a topic that I have been curious for a long time and now have a chance to explore and share information with you all. That is about our sun and its energy. So given a limited time, I will only focus in few topics, most important topics. First of all, what is solar energy? Then we will explore some of its important use, the pros and cons of solar energy, what are the environmental effects of using solar energy, and finally I would like to share some fun fact with you all. About the sun, so how important is this? Plants need sunlight to grow. Animals, including humans, need plants for food and the oxygen that they produce. So without the heat from the sun, the earth would be freeze, there would be no winds, ocean currents or clouds to transport water. So I would say it's really important. So just like the earth, sun have many layers too. The core of the sun, where energy is produced by hydrogen atoms being converted into molecules of helium. This process, technically known as nuclear fusion, and it releases an incredible amount of energy in the form of light and heat. The energy emitted from the photosphere, radiant energy, then propagates to space and reach Earth's atmosphere and other planets of solar system. The radiant energies from the sun represents the entire electromagnetic radiation, such as the light that we can see, ultraviolet, X-rays, and radio waves. So this energy empowers all life on Earth. There are two types of solar energy. First of all, there is solar thermal technology, which concentrate the sun power to obtain thermal energy or heat. This generates steam, which in turn operate a conventional turbine that produces electricity. The second one is the photovoltaic technology, use solar radiation or light to generate electricity by exploiting the chemical properties of certain material. This type of technology uses solar panels to capture the energy, then convert it to electricity. So let's talk about some uses of solar energy. So without any kind of equipment, solar energy provides daylight. So the image I'm showing right now is one example of the modern home design, which takes great advantage of this to reduce any other form of energy consumption. And the thermal energy collected from the sun can be used for water heating and space heating. The radiant energy from the sunlight can be collected to produce electricity, which in turn power all the electronics that we are now so dependent on. So there's some advantage that we can take from this source of energy. So solar is a renewable energy source. The potential of solar energy is abundant. The surface of the Earth receives 120,000 terawatt of solar radiation, sunlight, around 20,000 times more power than what we need to supply the entire world. And it is a sustainable energy source which meets the need of the present without compromising the ability of the future generation. In other words, the solar energy is sustainable because there is no way we can overconsume this type of energy. Besides this, many other applications, such as it can be used to generate electricity in places that have no power grid, for distilling water in Africa, or even power satellites in space. And lastly, it almost have no noise. So there's no moving parts involved in most applications of solar power. There's no noise associated with photovoltaics. This compares better to certain other green tech such as wind turbines. However, as many other sources of energy, renewable energy, solar energy also has some disadvantage. First of all, it's expensive, so solar installation can have high initial costs for converter, panel storage, and so on. And it is intermittent. This energy is weather dependent. So, for example, there's cloudy days, we can collect more sun power than versus less sun power versus sunny day. And it have transportation limitations. It's almost impossible to move your solar equipment. It's tough, expensive, and can be damaging. And it's also space consuming. A large solar system requires a decent size of space to install the equipment and have everything run smoothly. About 100 square feet of roof space is required for 1 kilometer watts for conventional solar panels. Besides, solar energy also have some environmental effects. First of all is the land use. So solar energy facility require a lot of land space. Estimate for utility scale PV system range from 3.5 to 10 acres per megawatt. And unlike wind facility, there's less opportunity for solar projects to share land with agriculture use. However, land impact from utility scale solar system can be minimized by setting them at a lower quality location, such as brownfields, abandoned mineland, or existing transportation. And besides, there's a water usage. So solar PV cells do not use water for generating electricity. However, as in all manufacturing process, some water is used to manufacture solar PV components. Concentrating solar thermal plants, like all thermoelectric plants, require water for cooling. And water use depends on the plant design, plant location, and the type of cooling system. Many of the regions in the United States that have highest potential for solar energy also tend to be those with dry climate, so careful consideration of these water trade-offs is essential. And it also contains a lot of hazardous material. The PV cell manufacturing process includes several hazardous materials, most of which are used to clean and purify the semiconductor surface. These chemicals, like those used in general semiconductor industry, like sulfuric acid, nitric acid, if not handled and disposed of properly, this material could pose serious environmental or public health threats. However, these manufacturers have a strong financial incentive to ensure that these highly valuable and often rare materials are recycled rather than thrown away. So it's actually a good thing. So lastly, I would like to share some fun facts with you guys. So this picture right here shows the solar power aircraft, which designed by NASA in late 2001. And the picture on the right is actually the largest PV plant in the world, which is the Tanger Desert Solar Park in China, and it covers 1,200 kilometers and output is 1,547 megawatt of power. And the last picture is show us the life cycle of the sun. So eventually it can become the red giant and become a white dwarf, which is basically a dead planet. However, we still have another 5 billion years before this will happen. and the first solar cell was constructed in 1880s. Thank you so much for your time today to listen to my PowerPoint. And this site is show all the work site that I collect information from. And hopefully after this PowerPoint, everybody can consider to use more renewable sources of energy. Thank you so much and have a good day.